This is the Eastern OptX Model 6067 Digital Altimeter Test Set. The system can vary altitude from 0 to 200,000 feet in 1-foot steps. The minimum altitude setting is 8.4 feet, and the propagation loss can be varied from 50 to 170 dB in 0.5 dB steps. The system may be operated in either the manual or coupled mode. In the manual mode, the altitude can be changed from the front panel as shown here. The loss may also be entered from the pop-up keyboard. Also available is the Antenna Installation Delay, or AID range. This feature allows the user to duplicate the delay associated with the aircraft cabling between the altimeter and the antennas mounted on the underside of the aircraft. The AID range is approximately 500 feet, and when used, can allow operation down to the 0-foot altitude, including test cables. The system may also be operated in the auto or coupled mode. In the auto mode, the propagation loss is coupled to the selected altitude. In this case, the system calculates the loss associated with a signal transmitted from an aircraft at 300 feet. The altitude is changed, then the system will automatically adjust the loss to the new altitude. The 6071 also features a scenario generator. This tool allows the user to create a flight scenario including ascent, descent, level flight, terrain variation, and optional Doppler shift. Scenarios may be created manually by entering information in the scenario table, including delay and loss. Once created, the scenarios may be stored and later recalled for playback. Multiple scenarios may be stitched together to create complicated flight patterns. Scenarios may be recalled using the Open soft key. In this case, a pre-stored scenario is recalled, and the scenario plot shows both the change in altitude and loss as a function of flight time. The scenario is launched using the Run key. Once the flight begins, the progress can be seen updating on the flight path. The flight status may also be queried via the Ethernet interface, and all commands available from the front panel may also be sent via the control interface. The scenario may be restarted using the Run key. In this scenario, the flight begins at 50 feet and then ascends to 90 feet in 10 seconds. It then rises to 300 feet, also in 10 seconds. All of these settings can be modified for different applications. Scenarios can be triggered manually or with a remote command. Using the remote command, the scenario can be coordinated with other test equipment and with the reported telemetry from the altimeter. The results, including the timing of the scenario, can be stored and reviewed against the altimeter telemetry. Details of the scenario are displayed in the scenario table. A preloaded scenario may be edited directly using a keyboard entry, or the table can be modified offline and then reloaded. In this case, the initial altitude of 50 feet is entered in step 001 of the scenario. The altitude then increases first to 90 feet in step 2 and then 300 feet in step 3. The duration of the ascent is 10 seconds. The change from 50 to 90 feet will take place in that 10 seconds. The loss is set by the auto mode selection. The loss will be tied to the scenario altitude and automatically updated to the proper loss associated with the next altitude. The loss interpolation between steps may be selected as auto, linear, or none. If none is selected, the change becomes stepwise. The gain key is used to enter the antenna gain for the altimeter network. Add the gain for both the receive and transmit antennas, as well as any AID cabling loss.